Stop making fantasy football trades and listen to this video. You know who you are. Anyway, this video is going to be answering some of the questions I asked on the bell ringer right before the test. Now, it's not going to be set up like the rest of the videos in that I have no idea what's next because I'm just going to read your questions. All I did was copy the questions down that you asked on the bell ringer, deleted the duplicates, I hope, and we're going to go from there. So, on to it. Question number 1. Why is it taking so long to switch over to renewable energy? Why do you think? Money. There's more money to be made in fossil fuels right now. There's more money to be consistent in what we've always used. There's more money in not switching over to something else that's different and new. It also takes time to develop these new technologies. And to be fair, the technologies aren't, as efficient as the ones we use now. So there's also that. What's the big driver though behind everything as always? Money. Can you clear up how nuclear energy works? Yeah, so nuclear energy, it basically takes a uranium atom, and it's U-235, and it sends a neutron, it hits that, and that one nucleus is then split, which then goes to hit other nucleus of uranium, which splits, which hits other, you get the idea. However, what's the big difference here? Well, in a bomb, we just keep letting that go. In nuclear energy, what we do is we have those control rods. Remember, they're the neutron absorbing material that can help speed up or slow down a reaction depending on how much we put into the reactor. Well, the more we let that happen, the more energy is given off, the more heat happens, the more steam we make. Steam goes to the turbine, turbine spins a generator, generator creates electricity. There you go. What's the difference between passive and active solar energy? Well, passive is like a greenhouse. It doesn't do anything. It's just like greenhouse. Active solar energy, it has a solar panel type thing on the roof where we collect it and we start to actively warm the water up by doing something to it. We're passing it through these pumps. We're making the water work for us to help go to, say, a water heater, so it has to do less work. So, passive, greenhouse, doesn't do anything. Active, we're pumping water through, we're trying to warm it up. Can you go over geothermal real quick in your video? Sure. Geothermal, what we use here is we take Earth's natural heat that we find when we dig down into the earth, and we then pump water into the ground through what we call the injection well. Well, that water is going to be heated up eventually by that heat that we find underneath the Earth's crust, and we pump it back up in the production well in the form of steam. Well, the steam then goes to a turbine, which spins, which is connected to a generator, which creates electricity. You get the idea there. What does GJ mean in energy? Gigajoules. It means joules, which is a measurement of work. Gigajoules, there you go. Technically, it's energy. Will we have to do any calculations on the test? Potentially, but they're calculations that you have already done, meaning they might be those flowchart things that I told you about. Hey, yeah, remember those were a thing. They might just be doing some simple gradient calculations like we talked about and we've done kind of off and on, or maybe it's just finding percentages like we talked about with the different types of energy on the front side of that worksheet with the big crazy loopy flowchart on the back. Well, we need to know what parts of the U.S. use what renewable energy. I gave you that map for a reason. I would look at it. The deserts are good for solar. The plain states are good for wind. The western states are good for geothermal. The, what's the last one I'm thinking of? Hydropower is near mountains or elevation changes. Those are the best places for them. Where can we use them? Anywhere that's suitable. If you go and look at the economics and the policy and the governmental, I know that you're all rolling your eyes and falling asleep as I say that, you find out that the states that use the most of them are not necessarily the ones that are in the best position to use them. A lot of it goes back to what that first question was, money and politics. What material do you want us to focus on mainly when studying? I know this is going to be annoying and you're not going to like the answer, but like if I gave you the stuff, I've pretty much whittled down to things that I think are important. But what would I study if you're only going to study anything? I would look over the notes that I gave you, look over the PowerPoint, and then anything that I like repeatedly emphasized in a class or a video, and I did like the hint, hint, nudge, nudge, wink, wink kind of things, or something that I said over and over and over again, I would probably study that stuff. Yeah. What is Trinity? Trinity was the first nuclear test. It's in New Mexico that really set off the nuclear age when we started the first atmospheric testing of a nuclear bomb. With all the questions, or will all the questions be related to the notes, or will we need to look at some of the links you posted? So the links are there to be supplemental. They're there to help you out. They're there to give you more context and more background and more feedback. They will probably help you on some of the short answers, but you can still do fine if you don't look at any of them, but I put them there for a reason. Is the test mostly going to be about how they affect the environment? Because you said we are mostly going to focus on climate change in this class. Sort of. We're gearing up to that. The next unit is climate, so we're going to talk about how all the choices and all the things and all the energy and all the decisions we just learned about affect climate. So we're getting there. Yes, good question. You're a little ahead of me. Be aware of that, though. I would definitely know the pollution and what the different types of energy sources release and how we get them in the mining and the pumping of oil and all that stuff, though. If I just study my notes packet, will I be in good shape? You'll be good. I won't say you'll be great, but you'll be good. You'll be fine. You'll pass. Are we going to have to remember the percentages of different elements for each energy source? No. You do not need to remember specific percentages because there's no set answer that I want you to have. Know that fossil fuels are a huge chunk of it. They're like 80% of it. And know that renewables and nuclear are both about 10% each, roughly. But you don't need to remember those specific numbers, no. What do we call radiation in the atmosphere after catastrophic events? I think you're talking about nuclear fallout. Can you go over where all the different sources are mainly located, especially for non-renewable, please? Okay, you're not going to need to know that, but I'll go over it. You'll need to know what they're used for. You'll need to know what coal is used for, what oil is used for, what natural gas is used for. I'm not going to ask you to remember where we found them, but coal is in bogs, marshlands, places like that, North America, Northern Europe. Those are the big places. Oil, shallow seas, mostly in the Mideast, but we do find it kind of everywhere. Don't worry about where you find them. Focus way more on how they're used and what they do. Confused about isotopes. Isotopes are basically elements that have the wrong number of neutrons. So remember, everything likes to be in nature as balanced as it can. It wants to, yeah, go ahead and make your Thanos memes. It wants to have, like, in carbon's case, 6 protons, 6 neutrons, 6 electrons. When it has 7, that's carbon 13 neutrons. When it has 8 neutrons, that's carbon 14. Isotopes are just the wrong number of neutrons attached to that protons. Some of you made this mistake I saw in the bell ringer. You cannot have the wrong number of protons. Why? That just makes it a different element. A carbon with 8 protons is not something, it's oxygen. You can't have a carbon with 8 protons. Best way to remember composition of coal, I don't really care. I just want you to know that carbon is the huge majority of it because it came from a living thing, because that's going to come up again later in climate. Is this going to be open notes? You all know the answer to that. The question above, I didn't really understand the question. So the question, I believe this is referring to, is on the bell ringer, which was, if we are 100% done with with fossil fuels, and we are 100% on renewables, are we really done with fossil fuels? Not for a long time anyway. Plastics, jet fuel, all that stuff that you can't really fly a plane with batteries anytime soon. So no, even if all of our energy went to renewables, we still have way too many non-synthetic things that we can make that we need fossil fuels for. We're working on it, not there yet. Are there certain topics where more questions than others? For example, will there be more questions about coal than oil? I will say I try to do about even amounts of everything, though fossil fuels maybe have a little more than nuclear. I don't know. I haven't made the test yet. Roughly the same, though. Any suggestions for what to specifically study? I've answered that. Stuff I've emphasized, stuff I've repeated, stuff you've seen over and over again, stuff I've given worksheets on. How long do you have to take the test? The entire class period. So by the time I'm done introducing it and giving you time to study, 75-ish minutes. How is most energy sources converted into the actual energy that we use? All I need you to know right now is the basic process of it probably boils water. That water goes to a turbine. That turbine spins, the generator spins, it creates electricity. You don't need to get any more detailed than that. What will happen if we can't all agree on a renewable energy source to switch over before we run out of non-renewables? Can you do a brief summary of the renewable energies? Went over geothermal already. Solar, basically, the one we talk about is solar panels. The sun hits the solar panel. It creates a stream of electrons. That electron then makes a circuit. The circuit then makes electricity for us. You have parabolic solar collection. We focus the mirrors onto a certain point. All that heat, steam, turbine, generator. Hydropower, dams. Dams have flowing water into a turbine, generator, you got it. And the last one is wind. It is the turbine, generator, you got it. How difficult do you think it is? Not that bad, but there's a lot of stuff. So I don't think anything is too complicated on its own. I do think that there's a lot of things, and if you don't pay attention, that can come back to bite you. How long will it take? 40 to 60 minutes, probably. Is there anything on the test about the periodic table? If so, do we get to look at the periodic table? No, not on this one. Yes, if I need you to, you'll have one. How many questions, or how many points will the short answer questions be? It depends on how many I put on them. Probably 5 to 8. I will make the test tomorrow and I will update all of you. How about that? Are we going to have to know the full history of nuclear energy and bombs? For example, Operation Castle and the nuclear accidents. Know why they're important. You don't need to know every single little detail. You don't need to know every single little latitude, longitude for the Marshall Islands or anything like that. Know why they were important. Know how they led us there. Know why Chernobyl was important. Know why 3 Mile Island was important. But it's not going to be the end-all be-all of the test. No, I would not spend a ton of time on that. I will give you that. Yeah, okay, so that looks like it. This is a long enough video anyway. Hopefully you got something from this. Hopefully your question was answered. If not, this will be posted sometime on Wednesday or probably Wednesday. You got another day if you're A, or 2 if you're B, to ask questions. Please do. I don't know how to help you anymore. I've given you everything. Be ready for it. Ask me questions. See you soon. Bye.